Hello students, welcome to the lecture on inventory management, and after this lecture we will be able to learn the following objectives. Explain inventory management and its functions, understand the key benefits of an inventory management system, discuss the various costs associated with inventory management, describe implementation lead time reduction, define EOQ model and buffer stock, describe ABC, SDE and VED analysis, explain reorder point and just-in-time of inventory management. Let us first talk about the inventory management. Inventory to many small business owners is one of the more visible and tangible aspects of doing business. Raw materials, goods in process, and finished goods all represent various forms of inventory. Each type represents money tied up until the inventory leaves the company as purchased products. In a literal sense, inventory refers to stocks of anything necessary to do business. These stocks represent a large portion of the business investment and must be well managed in order to maximize profits. In fact, many small businesses cannot absorb the types of losses arising from poor inventory management. Unless inventories are controlled, they are unreliable, inefficient, and costly. Inventory management is not limited to documenting the delivery of raw materials and the movement of those materials into operational process. The movement of those materials as they go through the various stages of the operation is also important. Typically known as a goods or work in progress inventory, tracking materials as they are used to create finished goods also help to identify the need to adjust ordering amounts before the raw materials inventory gets dangerously low or is inflated to an unfavorable level.
Excess includes a complete inventory management component with the ability to manage vendors, track purchase orders, item receipts, vendor bills, manage stock levels, and perform cost averaging calculations. Inventory items and elements can be organized and managed across multiple inventory locations, including warehouses, vehicles, and other locations where inventory items are stocked. Create purchase orders to track parts that have been ordered and use item receipts to manage the shipments that have been received. Vendor bills are input to determine how much money has been paid for the parts that have been received, and when parts are used on service orders, stock levels are automatically adjusted. Users can define reorder points and restock levels for each inventory item to help maintain stock levels as parts are used on the job. As stock levels are reduced and inventory parts are used on the job site, Elements uses the FIFO, first in, first out method of calculating the value of the remaining inventory on hand. Advanced audit tools and Elements provide the ability to perform end-of-year item counts and update inventory quantities on hand, helping to maintain accurate stock levels and valuations.
Let's discuss about inventory management concept. Inventory management is important for most businesses, even for those which do not sell any physical products. However, if you are a manufacturer, distributor, or retailer of any products, inventory is the lifeblood of your business. The smooth running and profitability of your business is very much dependent upon how effectively you manage various inventory items you use or sell. If you are a service provider where the availability of right items is vital to your ability to provide the service, effective inventory management is vital to your business. The key decisions for effective inventory management include what to order, how much to order, when to order, and when to schedule delivery. If you are a manufacturer, you have to make these decisions related to materials and components that are used in making the products you manufacture and also in relation to the product themselves. What are the key benefits of an inventory management system? A proper inventory management solution will streamline your business, by significantly reducing costs and waste. Accuracy. Eliminate human error in inventory counting. Speed. Reduce man hours by using automated data capture. Accountability. Document shrinkage and loss to identify steps to reduce them. Mobility. Make adjustments or replace damaged, unreadable labels on the spot using mobile computers and printers. Components of an inventory management system are: all inventory management systems consist of 4 core components. First component is inventory tracking software. The software you use will determine how you track your inventory. Support for real-time versus batch updates and the depth of reporting will determine which application is most appropriate for your business. Second component is mobile computer. Inventory tracking requires users to be on the move throughout your facility, making updates and changes. Depending on your environment and need for wireless communication, a range of devices can serve your process. Third component is wireless infrastructure. Many businesses need inventory updates to occur in real time, and a wireless network is a required tool to do so. No matter the size of your facility, a network can be scaled to accommodate it. Fourth component is barcode printer. In order to track items quickly and easily, they need to be labeled with a barcode. Printing can be done at fixed units for high volume printing or on the move with mobile printers. Let's now talk about various costs associated with inventory management. Inventory procurement, storage and management is associated with huge costs associated with each of these functions. Inventory costs are basically categorized into 3 headings: ordering cost, carrying cost, shortage or stock out cost, and cost of replenishment. Cost of loss, pilferage, shrinkage, and obsolescence, etc. Cost of logistics, sales discounts, volume discounts, and other related costs. Let's talk about these in detail. Ordering cost. Cost of procurement and inbound logistics costs form a part of ordering cost. Ordering cost is dependent and varies based on 2 factors: the cost of ordering excess and the cost of ordering too less. Ordering excess quantity will result in carrying cost of inventory, whereas ordering less will result in increase of replenishment cost and ordering costs. These 2 above costs together are called total stocking cost. If you plot the order quantity versus the TSC, you will see the graph declining gradually until a certain point, after which, with every increase in quantity, the TSC will proportionately show an increase. This functional analysis and cost implications form the basis of determining the inventory procurement decision by answering the 2 basic fundamental questions: how much to order and when to order. How much to order is determined by arriving at the economic order quantity, or EOQ. Carrying cost. Inventory carrying involves inventory storage and management, either using in-house facilities or external warehouses owned and managed by third-party vendors. In both cases, inventory management and process involves extensive use of building, material handling, equipments, IT software applications and hardware equipments, coupled managed by operations and management staff resources. Inventory storage and maintenance involves various types of costs, namely inventory storage cost. Inventory storage costs typically include cost of building rental and facility maintenance and related costs. Cost of material handling equipments, IT hardware and applications, including cost of purchase, depreciation or rental or lease, as the case may be. Further costs include operational costs, consumables, communication costs and utilities, besides the cost of human resources employed in operations as well as management. Cost of capital includes the cost of investments, interest on working capital, taxes on inventory paid, insurance costs, and other costs associated with legal liabilities. The inventory storage costs as well as cost of capital are dependent upon and vary with the decision of the management to manage inventory in-house or through outsourced vendors and third-party service providers. Current times, the trend is increasingly in favor of outsourcing the inventory management to third-party service providers. Just-in-time. Just-in-time is an inventory system where raw materials are delivered right before they are needed on the assembly line and finished goods are manufactured just before they are shipped to customers. Let's discuss about an economic order EOQ quantity model. The economic order quantity EOQ is the number of units that a company should add to inventory with each order to minimize the total cost of inventory, such as holding costs, order costs, and shortage costs. The EOQ is used as part of a continuous review inventory system in which the level of inventory is monitored at all times and a fixed quantity is ordered each time the inventory level reaches a specific reorder point. The EOQ provides a model for calculating the appropriate reorder point and the optimal reorder quantity to ensure the immediate replacement of inventory with no shortages. It can be a valuable tool for small business owners who have to make decisions about how much inventory to keep on hand, how many items to order each time, and how often to reorder to incur the lowest possible costs. The EOQ model finds the quantity that minimizes the sum of these costs. The basic EOQ formula is as shown, where TC is the total inventory cost per year, PD is the inventory purchase cost per year, price P multiplied by demand D in units per year, H is the holding cost, Q is the order quantity, and S is the order cost. HQ by 2 is equal to ST by Q, or Q is equal to the square root of 2ds by H. Model development. Using the principles of the classical EOQ model, the following assumptions are made. Demand rate is determinable and constant. Supplies are delivered in batches. Replacement is instantaneous on request. Inflation rate is assumed constant over a period of time. Unit purchase cost and other relevant costs are affected by inflation. Shortages are allowed at a cost and over a given back ordering time frame. Purchase costs per unit change with quantity with discount. To derive a lot size formula, the following assumptions about manufacturing systems are made. Production is instantaneous, there is no capacity constraint, and the entire lot is produced simultaneously. Delivery is immediate, there is no time lag between production and availability to satisfy demand. Demand is deterministic, there is no uncertainty about quantity or timing of demand. Demand is constant over time. In fact, it can be represented as a straight line so that if annual demand is 365 units, this translates to a daily demand of 1 unit. A production run incurs a fixed setup cost. Regardless of the size of the lot or the status of the plant, the setup cost is the same. Products can be analyzed individually. Either there is only a single product or there are no interactions. Example, shared machines between products. 2 key insights of EOQ. The obvious implication of the above formula is that the optimal order quantity increases with the square root of the setup cost, or the demand rate and decreases with the square root of the holding cost. However, a more fundamental insight is the realization that there is a trade-off between lot size and inventory. Increasing the lot size increases the average amount of inventory on hand but reduces the frequency of ordering. Let's talk about buffer stock. A buffer stock scheme, commonly implemented as intervention storage, the ever normal granary, is an attempt to use commodity storage for the purposes of stabilizing prices in an entire economy, or more commonly, an individual commodity market. Specifically, commodities are bought when there is a surplus in the economy, stored, and are then sold from these stores when there are economic shortages in the economy. Buffer stock schemes seek to stabilize the market price of agricultural products by buying up supplies of the product when harvests are plentiful and selling stocks of the product onto the market when supplies are low. Objectives of buffer stock. The buffer stock are required to feed TPDS and other welfare schemes, ensure food security during the periods when production is short of normal demand during bad agriculture years, stabilize prices during periods of production shortfall through open market sales. Working capital cost. Working capital, abbreviated WC, is a financial metric which represents operating liquidity available to a business, organization, or other entity, including governmental entity. Along with fixed assets such as plant and equipment, working capital is considered a part of operating capital. If current assets are less than current liabilities, an entity has a working capital deficiency, also called a working capital deficit. Let's talk about lead time. The lead time is the duration between placing an order until receiving the order. This term is used in the production planning. Lead time reduction. Reducing lead times does not involve speeding up equipment to cut the cycle times or getting plant personnel to work faster. What do involve are the rapid fulfillment of customer orders and the rapid transformation of raw materials into quality products in the shortest amount of time possible. Implementing lead time reduction. Measure current lead times and set improvement targets. Lead times, as important as they are not measured in most organizations. People may have a sense as to the planning horizon, but cannot say how long it took for individual products to cross the value stream. Things that are not measured cannot be improved. Change the organization from a functional orientation to a product orientation. If possible, all resources required to produce a product shall be located close to each other. These product-focused groups are called work cells or cellular manufacturing. Include office operations, as these functions often account for half of total customer lead time. Cross-train plant personnel within cells in a number of operations for greater flexibility. Reducing the number of job classifications and maintaining multi-skilled teams on each shift is critical to rapid response manufacturing. Empower work cells and teams to take ownership for the entire value stream. Drive accountability for product cost, quality and delivery down to the lowest appropriate level, ideally the operators themselves. Continually reduce batch sizes between work centers. With operations in close proximity, transfer batches can be smaller and WIP inventories can be minimized. Institute local scheduling between work cells. Visual shop floor scheduling tools like KANBAN systems can be used to minimize WIP between cells and to eliminate queue time throughout the value stream. Let's talk about reorder level fixation. Fixation of various inventory levels facilitates initiating of proper action in respect of the movement of various materials in time so that the various materials may be controlled in a proper way. However, the following propositions should be remembered as: only the fixation of inventory levels does not facilitate the inventory control. These have to be a constant watch on the actual stock level of various kinds of materials so that proper action can be taken in time. The various levels fixed are not fixed on a permanent basis and are subject to revision regularly. The various levels which can be fixed are: maximum level. It indicates the level above which the actual stock should not exceed. If it exceeds, it may involve unnecessary blocking of funds in inventory while fixing this level. Hence, following factors are considered in the maximum level: maximum usage, lead time, storage facilities available, cost of storage and insurance, etc., prices for material, availability of funds, nature of material. Example, if a certain type of material is subject to government regulation in respect of import of goods, etc., maximum level may be fixed at a higher level. Economic order quantity. Minimum level. It indicates the level below which the actual stock not reduces. If it reduces, it may involve the risk of non-availability of material whenever it is required. While fixing this level, following factors are considered: lead time, rate of consumption, reorder level. It indicates that level of material stock at which it is necessary to take the steps for the procurement of further lots of material. This is the level falling in between the two existences of maximum level and minimum level and is fixed in such a way that the requirements of production are met properly till the new lot of material is received. Danger level. This is the level fixed below minimum level. If the stock reaches this level, it indicates the need to take urgent action in respect of getting the supply. At this stage, the company may not be able to make the purchases in the systematic manner, but may have to make rush purchases, which may involve higher purchase cost. Let's talk about ABC analysis. ABC analysis is a type of analysis of material dividing in three groups called A group items, B group items, and C group items, for the purpose of exercising control over materials. Manufacturing concerns find it useful to divide materials into three categories. An analysis of the annual consumption of materials of any organization would indicate that a handful to top high value items, less than 10% of the total number, will account for a substantial portion of about 705 of total consumption value. Advantages of ABC analysis. It ensures a closer and a more strict control over such items which are having a sizable investment in there. It releases working capital which would otherwise have been locked up for a more profitable channel of investment. It reduces inventory carrying cost. It enables the relaxation of control for the C items and thus makes it possible for a sufficient buffer stock to be created. It enables the maintenance of high inventory turnover rate. Here we talk about STE analysis. The STE analysis is based upon the availability of items and is very useful in the context of scarcity of supply. In this analysis, S refers to scarce items generally imported and those which are in short supply. D refers to difficult items which are available indigenously but are difficult items to procure. Items which have to come from distant places or for which reliable suppliers are difficult to come by fall into D category. E refers to items which are easy to acquire and which are available in the local markets. The STE classification, based on problems faced in procurement, is vital to the lead time analysis and in deciding on purchasing strategies. This classification runs like this. S is equal to scarce items, D is equal to difficult to procure items, E is equal to easy, not difficult to get items. STE analysis is done based on purchasing problems associated with items on day-to-day basis. Let's discuss about VED analysis. The VED criticality analysis of all the listed items was performed by classifying the items into vital V, essential E, and desirable D categories. The items critically needed for the survival of the patients and those that must be available at all times were included in the V category. The items with a lower criticality need and those that may be available in the hospital were included in the E group. The remaining items with lowest criticality, the shortage of which would not be detrimental to the health of the patients, were included in the D group. The VED status of each item was discussed with justification by a group comprising of physician, surgeon, pediatrician, and pharmacist. Let's talk about KANBAN system of inventory management. KANBAN is a concept which attempts to maintain minimum inventory. The KANBAN process involves more than fine-tuning production and supplier scheduling systems where inventories are minimized by supplying these when needed in production and work in progress in closely monitored. The essence of the KANBAN concept is that a supplier or the warehouse should only deliver components to the production line as and when they are needed so that there is no storage in the production area. In order to be effective, KANBAN must follow strict rules of use, and that close monitoring of these rules is a never-ending problem to ensure that KANBAN does what is required. In a KANBAN system, communication occurs by a successor workstation that issues a request for parts to the output buffer of a predecessor work center. Now, in the end, let us summarize what we have learnt in this lecture. Inventory management is the process of efficiently overseeing the constant flow of units into and out of an existing inventory. Economic order quantity, EOQ, is the level of inventory that minimizes the total inventory holding costs and ordering costs. Buffer stock is a stock held to reduce the negative effects, stock out costs of an unusually large usage of stock. Lead time is the time between the initiation of a process and its completion. ABC analysis is that technique of material control in which we divide our material into 3 categories and investment is done according to the value and nature of that category's materials. The STE analysis is based upon the availability of items and is very useful in the context of scarcity of supply. JIT, or just-in-time inventory, is an inventory management strategy that is aimed at monitoring the inventory process. A KANBAN system is a mean to achieve just-in-time JIT production. It works on the basis that each process on a production line pulls just the number and type of components the process requires at just the right time.